Hi, and welcome to Electrical Engineering Basics. In this course, I'm going to teach you step by step, with a clear explanation, all about electrical engineering fundamentals, including electrical engineering basics, electrical wiring, symbols used in electrical field, and much more. Upon completion of this course, you will learn electrical wires and switches, electrical grounds, electrical measuring devices, electrical cells and batteries, electrical power supplies, electrical fuses, electrical inductors, electrical transformers, electrical relays, electrical wires and cables, electrical bulbs, electrical circuits diagram, and much more. I want to add that I will upload this PowerPoint file with the course in order to use it as a basic reference for you. In addition, this is three things that I want to add. This course is created with perfect care by a professional in electrical, electronics, and schematics analyzing electrical wires and switches. So let's get started. So as you see here, the first symbol is a symbol for a simple wire, okay, as you see, or cable. This is another symbol for two wires. So we have here intersection of two wires, but these two wires is not connected. Okay, so this symbol means these two wires is not connected. The same for this. Okay, as you see, so we have the intersection here, and here we have a bridge. So this symbol or this means no connection over here. Okay, we can add another symbol that means the same, no connection. If you find this or this with a bridge, or even if you found like this. So we have a cable here, and we have another cable, and here empty. Okay, a divided cable. This means not connected. So if we go here, as you see, we have exactly like this symbol, as you see, but we have dot over here. This means there is a connection. This is a connected wires because we have these dots. Okay, the same for this symbol. We have three dots, means all these wires are connected together. Okay, for this symbol, we don't have here a dot but a circle. So this is a switch, a closed switch. Okay, exactly like this one, but this switch is closed. Okay, so here we have a switch, a normal switch. As you see, we have this pole over here, pole. This switch is a single pole, single throw. So this is pole and this is throw. So this is a single pole, okay, because we have just one pole, and single throw because we have just one throw over here. Okay, but for this, so we have one pole and double throw. So this is a single pole, okay, exactly like this one pole and double throw. Okay, so this is SPDT switch. We can find another switch with double pole, double throw, or even double pole with three throw, etc. Okay, for this is a switch or a circuit breaker. Okay, this symbol is for the circuit breaker. Okay, here this is another switch, but this switch is not like this. This switch has a fuse over here, so this is a fused switch. We call this switch a fused switch, okay, because it has a fuse for the protection, okay. So this is another switch. This is a normally open switch. This switch is a push switch, so you push this switch in order to activate it. So this is normally open switch, so N O, okay, means normally open. But for this is a normally closed, okay, as you see, NC, normally closed. When you push it to down, it will be opened, but normally it is closed. But for this, when you push it, okay, it will be closed, but normally it is open, okay. So we have here normally open switch and normally closed switch. For this also, this is the same as this, okay, the same as this, okay, normally open switch. Even if you find a dot or circle, the same, okay. So for this, we have two poles, okay, we have two poles and we have just one row here, okay. We can add one row here, but all these poles are controlled with one inductor, okay. You can see that all these poles, for example, are controlled with one inductor, okay. If we add here inductor, this is a relay, not a switch. But without this inductor, this is a switch with double pole. So this is a double pole, okay, DP, okay, double pole, okay, single throw. This is a single throw. Even if we have two throw, but these two poles are moved in the same time, okay. That's why this is a double pole single throw, okay. So here, this is a MOSFET, okay. This is a symbol of MOSFET, but this MOSFET works as a switch, okay. Almost all MOSFETs works as a switch, okay. So this is a switch or a MOSFET, because when this MOSFET or this switch receives a signal here, a control signal, the current will flow in this direction, okay. The current will flow in this direction. But when this signal is absent, the current will stop flowing. So this MOSFET works as a switch, so it will be on off in accordance with the received signal, okay. So this MOSFET is exactly like this, okay. So actually, this is the main important things that every engineer or technician in electrical field have to know, okay, in order to understand the electrical schematics and circuit diagram. You should first understand some basics like wires, switches, electrical component symbols, etc. The electrical grounds. So let's get started. As you see over here, we have three types of grounds, okay. So this is analog ground, okay. So this is AJ, okay. This is analog ground, okay. And this is the digital ground, okay, DJ, okay. And this is the chassis ground, okay. So three types of ground. So this ground, we find it in every setup, every electronic circuits, okay. This is the main used ground, okay. You find it everywhere. But for this is a digital ground. We'll find it in some micro electronic circuits and electronic motherboards, okay. And often we find it with the integrated circuits, okay. And for this is a chassis ground. This ground is connected to the chassis, okay, to the chassis. Let's assume, for example, the chassis of a car, for example, okay? Or everything that has a chassis, you will find this kind of ground, okay? So this is the analog ground, digital ground, and chassis ground. I'm going to say electrical measuring devices. So let's get started. So as you can see here, we have 6 symbols of electrical devices, okay? So the first symbol is for a voltmeter, okay? So this is the symbol of a voltmeter that we use to measure the voltage, okay? And this is the symbol of ampere or the ampere meter, okay? That we use to measure the amps. This symbol is the ohm meter, okay? So we use this to measure the resistance. And for this is a milliohm meter. Okay, this is a milliamp meter. We use it also to measure the current. Okay, and for this symbol, this is a galvanometer. Okay, the symbol of the galvanometer. We use this device to measure a small electrical current. Okay, and for this, the last symbol is the oscilloscope, the symbol for oscilloscope. Okay, so the oscilloscope device is used to measure the frequency and to check the frequency oscillation and forms. Okay, so this is an oscilloscope. Okay, so 6 devices: voltmeter, ammeter, ohm meter, milliamp meter, galvanometer, and oscilloscope. We're going to see electrical cells and batteries. So let's get started. So as you see here, we have 5 symbols. Okay, so the first symbol is for a cell. Okay, so this is a symbol for a cell, one cell, with plus and minus here. Okay, so for this symbol, the second symbol is double seal. As you see, we have the first, okay, and the second. So this is a symbol of for double seal, okay, with plus and minus. And here, this is a symbol for 3 cells. As you see, this is the first, the second, and the third, of course, with minus and plus. Okay, so this is 1 cell, double cell, and 3 cells. Okay, and for this is 1 cell and this is another, but we have here some dashes. Okay, this symbol is for mini cells. We have here mini cells. Okay, maybe 4, maybe 6, and more. Okay, so this symbol is for mini cells. And for this, with this arrow, okay, so this symbol is exactly like this with 2 cells, okay, and this arrow. This means a variable DC voltage or adjustable DC voltage. Okay, so this is symbol of 1 cell, 2 cells, 3 cells. We have here many cells and adjustable DC voltage. In this class, electrical power supplies. So let's get started. The first symbol is for EC. Okay, as you see, this is the symbol of EC voltage. Okay, so this is the AC voltage source symbol. Okay, and for this, as you see, we have here 2 dashes or 2 lines with a plus here. Means this is a DC voltage source. Okay, and for this, as you see, this circle with this arrow means the current source. Okay, this is a current source symbol. For this, so the same arrow but with this shape means a controlled current source. Okay, so this is adjustable current source or controlled current source. Okay, and for this we have plus and minus with the same shape. So this shape means controlled source. So because we have plus and minus, this is a controlled or adjustable DC voltage. Okay, so for this is the same as this. Okay, the same, but often this is the symbol that is used. Okay, so this is the AC voltage source. Okay, and for this, because we have here plus and minus, some technicians thought that this is a DC voltage source. No, this is not. This is just a jack. As you see, this is the plus part and this is the minus part. Laptop adapter has this type of jack, okay, exactly like this. So we have here, so this is the pin that is inside the circle. So let's assume that this jack is for laptop. Okay, so the pin that is here in the center is this. Okay, is plus, and this, okay, this is a minus part. Okay, so we have here the AC voltage source, the DC voltage source. Okay, because we have the plus and tall lines, we have the current source and adjustable or controlled current source. Here, adjustable DC voltage source, and also here this is the AC voltage source, and this is a jack, not the DC voltage source, just a jack. Going to see electrical bulbs or lamps. So as you see over here, we have three symbols for bulbs. Okay, so this is the standard symbol, as you see. So this is the symbol that is used often. So this is a symbol of a lamp or bulb. Okay, so this is another symbol. So this and this is the same. So this is another symbol. Okay, and this symbol is for a flashy lamp or bulb. Okay, this is flashy because we have here this symbol, like a square, means flashing. Okay, and always we find this lamp into circuits. So this is a circuit. Okay, as you say, let's assume that we have here plus and we have here minus. Okay, let's assume, for example, we have here 3 volts. Okay, DC. Okay, so if this switch is closed, okay, this lamp simply will be lit. So this is 3 symbols, okay, for bulbs, and this is a flashing lamp. Okay, electric fuses. So let's get started. So as you see over here, we have 5 electric fuses symbol. Okay, so this is the first symbol. So this symbol is for a fuse. Okay, so this is the first symbol, and this is the second with a line across this rectangle. Okay, this is another, okay, symbol, and here we have another symbol. So this is a fuse. Normally this symbol is for a switch. Okay, so this is a switch. Okay, but this switch has a fuse in it, so we call this switch a fused switch. Okay, anyway, we have here a fuse. Exactly, this symbol is like this. Exactly. Also, this is another symbol for a fuse, but this symbol is an old symbol. Okay, so this is an old symbol. Okay, often we use these 3 symbols, as you see here. This is an old symbol. Okay, so as you know, the fuse is used to protect electronic motherboards. Okay, so always we find the fuses in the beginning of each circuit or each motherboard, because its main role or purpose is the protection of other components in the motherboards. Okay, the electrical inductors. So as you can see here, we have 4 symbols here of electrical inductors. Okay, so the first symbol, as you see here, is a normal inductor or coil. Okay, so this is the symbol of inductor. Okay, or this, the same as this. So this symbol and this is the same. Okay, and here we have an inductor with these 2 lines. These 2 lines means iron. This is an iron inductor. Okay, so here we have a normal inductor as exactly as this one, plus an arrow, as you see. So this is a variable inductor or adjustable inductor. Okay, so the first inductor, as you see, this is a normal inductor. Always the letter that present or represent inductor is L. Okay, so this is L. Sometimes we find L, and sometimes we can find a PL, especially in laptop motherboards or computer motherboards. So L or PL. Okay, so we have an inductor, another inductor, the same principle. So this is iron inductor, and here we have a variable inductor. Okay, the electrical transformers. Okay, so this is 3 symbols for an electrical transformer. Okay, so we have this symbol, as you see, this is 2 inductors. Okay, when you find 2 inductors like this, means a transformer. Okay, so this is another symbol for inductor or for transformer. Okay, so this is another symbol for the transformer. As you see, we have 2 inductors. As you see, this is the first and this is the second, exactly like this, with tall lines. These tall lines means this is a metal. Okay, this is a transformer with metal in it. Okay, this is another symbol for the transformer. Okay, so we have 2 inductors, as you see here, and we have these 2 lines, metal. Okay, and we have this arrow. This arrow means a variable or adjustable transformer. Okay, so always the transformer has 2 inductors, the primary and the secondary. So this is the P primary inductor or the primary winding, and this is the secondary winding. Okay, to see electrical relays. Okay, so as you can see over here, you have relay symbols. Okay, so the first symbol, as you see, so always the relay composed of an inductor and a switch or more. Okay, so as you can see here, we have here inductor, as you see. So this is the first component of a relay, inductor. The second is the switch, as you see here. Okay, so inductor and switch. When this inductor is powered with a power, so this switch will be closed. Okay, so for example, let's assume that this relay is a 12-volt relay. Okay, so 12-volt relay. So when 12 volts pass through this inductor will be charged with current, and then this switch will be closed automatically. Okay, so the same principle here. So we have here inductor. So this is an iron inductor. Okay, because we have inductor here with 2 lines, means iron inductor. Okay, and we have here a switch, as you see. So for this switch, this is 1 pole and 1 throw. So this is SP. Okay, as we see before, this is SP S3T. Okay, is true. Okay, this is single pole, single throw. Okay, and here we have 2 throw, double throw. So this is a single pole. Okay, double throw. DT means double throw. Why? Because we have here 2 throw. Okay, we have 1 pole and 2 throw. So And here we have inductor. This is iron inductor. When this inductor is charged with current, okay, let's assume, for example, here we have 24 volt, for example, okay, so this switch will be energized, will be passed to this true, okay, will be connected. This line will be connected to this, okay. So the same here, the same. So this is a conductor. This is inductor, okay, the same. So this is inductor. Even if we have the shape, this is inductor, the same. If we have, for example, the voltage here, this switch will be operated, okay. So we have here a normally open, as you see, in O, and here we have a normally closed, okay. So let's assume that this switch is a normally closed switch, but when this inductor is charged with electrons, this pole will go to this true over here, okay, the same as this. So this is a single pole, okay, double true, exactly like this, okay, and this is a common, okay, a common point, okay. So for this, the same, we have here inductor, and we have a switch here, as you see, with double true. So this is single pole double true, okay, exactly like this and this. Here we have another relay, okay. So we have inductor here with these lines, we have 3 lines, and this is an arrow inductor, okay. So let's assume another time that we have, for example, here 12 volts, okay. So this pole will go to this point or true, okay. So let's assume that here we have NC, the same as this, okay, and here we have NO, okay, and here we have the common point, okay, the common point, okay. So this inductor control the switch. Always in the relay, the inductors control the switch, okay. Here we have an inductor, as you see here, with 2 switch, okay. We have switch number 1 and switch number 2. So this inductor control the both switch, okay. Each switch has 1 pole and double true, okay. So this is single pole double true, and this is a single pole double true, okay. So this is 2 switch with an inductor. So this is a big relay, as you see here, okay. So this is all about relay. This is the main working principle of the relay, okay. So the relay has 2 major components, the inductor and the switch, and the inductor controls the switch. When the current passes through the inductor, it will be charged and the switch will be operated on or off in accordance with its state. In this class, the electrical cables, okay. So as you see here, so this is many symbols, as you see here, okay. So we have some symbols that we already see before, and we have other new symbols, okay. So the first, okay, so the first symbol is a wire, a normal wire. Here we have unconnected wires, as you see, unconnected wires, okay. So we have the symbol or this, okay, or even this, okay. Here we have a connected wire, as you see. This is connected wire because we have here dots, okay, as you can see here. Okay, we have dots means connection, okay, and here we have exactly this wire, okay, as you see, the same wire with this dash here, with this symbol, this line here, okay. So this means what? Means this cable has 1 cable in it, okay. This is a cable with 1 cable in it. For this, okay, so here we have 1. For this, we have this line with these 2 small lines, means 2 cables, okay. This is a 2 cables, okay. This is a cable with a 2 cables in it, okay. Here we have 3, okay, as you see, 3 small lines means this is a cable with a 3 cable in it, okay, and so on. Or another symbol, the same, okay. So this is this and this and this, so this is the same, the same. You can find in some symbols or in some electrical circuits, these symbols, as you see here, okay, these symbols or this. So the same principle. So we have this, as you see, the normal line with the small line, as you see, with 1 or 2 or 3 or even 4, 5, 6, 7, 8, okay, and so on. So the number here means the number of cables. Okay, the same here. This lines means the number of cables. Okay, so this is for this we have this cable line with this circle that is scattered like this, means this is a shielded, okay, a shielded cable. Okay, this is a shielded cable symbol, and this is a coaxial cable symbol. Okay, so we have here a line or a cable, normal line. We have here unconnected wires or a wire. We have here connected wires, as you see. We have here a cable with one wire, cable that contains two wires, cable with three wires. Okay, the same cable with one wire, two wires, and three wires. Here we have a shielded, the symbol of a shielded cable. Okay, and here this is a coaxial cable. Okay, electrical symbols. So as you can see over here, we have here the first symbol is a symbol for a resistance. Okay, we have here a resistance, okay, or a resistor. So this is a symbol of a resistor, but this symbol is a US symbol. There is another symbol for an international resistor that is exactly like this. Okay, this is international symbol for the resistor. Okay, so this is international symbol, exactly like this. Okay, so this is a normal resistor. We have here a variable resistor. Always a row like this means variable or adjustable or controlled. Okay, so this is a variable resistor. We have here another symbol for resistor. This is a variable resistor. Okay, so this is international symbol, and this is a US symbol. Okay, so also this is a resistor with this arrow. Okay, means a potentiometer variable resistor. So this is a potentiometer variable resistor that you can adjust using your fingers or using a screwdriver, for example. Okay, so this is a capacitor. This is a normal capacitor. Okay, we don't have it in a sign, and this is a chemical capacitor or electronic capacitor with here plus, okay, and minus. Okay, so here this is LED diode. Okay, so this is LED diode. Okay, as you see, this is the symbol of a normal diode. As you see, we have here the anode, okay, or the plus, and the cathode, okay, or the minus terminal. Okay, with these two arrows means light emitting diode. Okay, so this is another symbol for the capacitor. This is a chemical capacitor. Of course, we have here plus and minus. Okay, so this is not a diode. We have here two inputs. Okay, the first input and the second input, and here we have the output. This is an amplifier. Okay, this is an amplifier. Let's assume that we have here minus and plus. Okay, so this is an amplifier symbol. Okay, here this is a triac. Okay, this is a triac. Okay, so two diodes, as you see, like this means a triac. Okay, so this is a triac. Okay, okay, this is not a transistor. So this is the symbol of transistor, but we have here two arrows, means this is a phototransistor. Okay, so the symbol of the transistor, the normal transistor, is exactly like this. Okay, as you see, exactly like this, with the base here, okay, the collector here, and the emitter here. Okay, so let's assume that we have this arrow here. Let's assume that this is an NPN transistor, because always the arrow show to us if the transistor is a PNP type or NPN type. When the arrow goes from base to emitter, okay, the transistor is NPN, okay, NPN transistor. Okay, so NPN transistor, because this arrow goes in this direction from base to emitter. But if the arrow goes in this direction, okay, so from emitter to base means a PNP, a positive transistor, okay, a PNP transistor. Okay, but for this, here we have base, okay, so the voltage here is the control signal, the voltage or the current. But here in the base, okay, the control signal is not current or voltage, is the light. As you see, we have two arrows means light. Exactly as you see here, we have two arrows means LED light emitting diode. This diode emits the light. But here, when this transistor receives light here, the current will flow in this direction, so from collector to emitter. Okay, so the light is the control signal for this kind of transistor, for the photo transistor. Okay, so of course we have here the symbol of transistor, as you see. So we have the collector, emitter, and base, and we have this arrow in this direction from base to emitter, means this is NPN. Okay, NPN transistor. Okay, so here we have a diode. So this is the symbol of the diode. Okay, we have two terminals. For diode, two terminals. We have the positive terminals and the negative terminals, or the anode and cathode. Okay, so always the current flow is in this side. Okay, but in this side is blocked. Okay, as you see, it's blocked. Okay, this is the optocoupler or opto-isolator symbol, as you see. So this is the optocoupler symbol that we find in the SMPS mode power supply or the switching mode power supply. Okay, so this component composed of two components inside. This is an LED diode, exactly like this one. As you see, we have diode with two arrows, means light emitting diode. And we have here a triac, exactly like this. You can find here a triac or a phototransistor, the same principle. Okay, so the control signal here is the light. Okay, so this is the optocoupler. We find it always in the switch mode power supply. Okay, so this component protects so other stage in the power supply motherboards. Okay, so this is a resistor, normal resistor. We have here the variable resistor. Okay, this is another symbol for the variable resistor. Okay, we have here the potentiometer of variable resistor. Capacitor, this is an electrolytic or chemical capacitor or polarized capacitor, because we have plus and minus. We have here an LED diode or light emitting diode. This is a capacitor, polarized capacitor. We have here amplifier with two inputs and output. Okay, this is a triac. This is a phototransistor. We have here the opto-isolator or optocoupler. This is a symbol of diode. This is a transistor, NPN transistor, because this arrow is in this direction. Okay, electrical circuits. So let's get started. So the first electrical circuit, as you see, so we have here cables, as you see. So this is cables. Okay, this is cell. We have here just one cell. Okay, as you see. Okay, we have here switch. So when this switch is closed, automatically the current will pass from the negative terminal to the positive terminal and then pass through this lamp or bulb, and then this lamp will be illuminated. Okay, so I have here lamp, switch, this is cell, and all these are cables. Okay, this is a basic electrical circuit, as you see, with lamp over here. Okay, and we have here a cell, okay, and a switch. So this is a basic electrical circuit. Okay, without any resistor or capacitor or even inductor. Okay, so here, so we have another electrical circuit, as you see here. So this is a cell. Here we have here switch, the first switch, as you see here. we have the second switch and the third switch. So here this is a parallel setup. Okay, so this is a parallel setup. When the switch is closed, the current will, as you see, the current will goes from negative terminal through this switch and then goes through this two switch. Okay, so when you close, for example, the switch, this bulb will be lit or eliminated, and when this is closed, these two lamps will be eliminated. Okay, so this is the working principle of parallel setup, not series setup. Okay, so for this circuit, as you see, we have a resistor. So this is a symbol of a resistor. So this or this, as you see here. So we have, for the resistor, there is two symbols. This is international symbol and this is a normal symbol, a US symbol. So we have here resistor and we have here V1 and V2. So this is the source of DC voltage, two DC voltage source. This is the first and this is the second source. Okay, so we have here two DC voltage source in this circuit. Okay, here we have some components, as you see here. So we have here a source, a DC voltage source, as you see. So the current will pass from the negative terminal to the positive terminal. As you see, we have here I, so this is the current will pass through this capacitor. We have here a capacitor, as you see, and we have here two components. This is a resistor and this is inductor. Why? Because we have here R. R means resistor. Okay, exactly like this. And this is L, inductor. Normally the symbol of inductor is this. Okay, I have L, inductor. Okay, for this, the last circuit is for an switching mode power supply. As you see, we have here a transformer. Normally this is a classic power supply, not switching mode power supply, because with the switching mode power supply we don't find the transformer in the beginning. We find the transformer normally here, okay, in this side, okay, after the capacitor, and after, normally we have here capacitor, as you see here. So normally we have here capacitor, a chemical capacitor or a filtering capacitor, and here in the switching mode power supply you will find here the fuse here and the electromagnetic interference, okay, inductor. But with this circuit we have the transformer here, means this is a classic power supply. Okay, so we have a transformer, as you see, this is the first or the primary winding, as you see, and this is the secondary winding. Okay, and here we have the rectifier with 4 diodes. Okay, this is the rectifier and this is the filtering capacitor, etc. Okay,